In question 2 of our molar mass of a gas series, we're asked, a sample of gas has a mass of 827 milligrams. Its volume is 0.270 liters at a temperature of 88 degrees Celsius and a pressure of 975 millimeters of mercury. Find its molar mass. I'll denote molar mass as capital M, and I'll put a question mark. What we've been given is the mass, and that is 827 milligrams. 827 milligrams, and keep in mind that there's a relationship between mass and molar mass. If you take the mass and divide it by the number of moles, you get the molar mass. And usually we use grams per mole. So this question mark, grams per mole. This suggests that we should change milligrams into grams, and we can do that easily. We can do that right now by dividing it by 1,000. So if we divide this by 1,000, we get 0.827 grams. Furthermore, we've been given the volume, and the volume is equal to 0.270 liters. Our temperature is in Celsius, 88 degrees, and our pressure is in mmHg. That needs to be converted into atmosphere, and I'm going to explain to you why. Our gas constant is 0.082057. I'm going to borrow this from question number 1. It's a given number. R is equal to 0.082057. And the units of this, as shown right here, are liters times atmosphere over moles times Kelvin. Given that the units of this gas constant is in ATM and is in Kelvin, this needs to be in ATM and this needs to be in Kelvin. So let's go ahead and convert that into Kelvin. We can take 88 and add 273.15. This gives us 361.15. 361.15, where the last significant figure is this 1. So I'll put a dot underneath that 1. To go from mmHg to ATM, we'll multiply this by 1 ATM over its conversion factor, which is 760 millimeters of mercury is 1 ATM. So I write down 760 here. And by orienting this conversion ratio into this fraction in this way, this unit and this unit will cancel out, leaving us with atmosphere. I'm going to find out what that is. 975 divided by 760 gives us 1.2828. 1.2828, and the last significant figure here is this 8. Notice that I did not round either of these numbers, and the reason why is because we're not done calculating. We don't want to run into rounding errors, so we just keep the number the way it is until the very end. So now I have everything that I need except for the formula that binds it all together, and that formula is PV is equal to nRT, where n represents the number of moles. Remember the relationship for molar mass, it's mass over number of moles. So by finding what n is equal to, I can then take the mass, what I'm hovering over, and divide it by the number of moles. To isolate for n, we divide both sides by RT, giving me PV over RT is equal to n. I'll substitute 1.2828 into here. That part's done. I'll substitute the volume, which was 0.270. The gas constant was 0.082057. And the temperature we found to be 361. Our final answer needs to be reduced down to 3 significant figures as well. Not the number that we get here, but the number that we get when we find the molar mass. Let's use our calculator for this. Taking the number that I have on my screen times 0.270 divided by everything in the denominator of this fraction. That's the gas constant times the temperature. And we end up with 0.01168. 0.01168, and this is the number of moles. So I'll take this number and divide 0.827 by it. 0.827 divided by, that's the mass, by the molar mass, the number that I just found, and we end up with 70.75. 70.75 grams per mole, we need to make this into 3 significant figures. Since this is odd and it's followed by a 5, the first discarded number, this makes the 7 become an 8, and our final answer is 70.8 grams per mole of this unknown gas. And there you have it. That is how to calculate molar mass of a gas.